And can you check my sound on YouTube? Can anybody go to YouTube and just check the sound? Yeah, just check the sound. Yeah, and you guys can join. Just few you guys can join the YouTube. Share. I'm gonna present this thing. Share screen. I'll share this browser. Okay, that's fine. So for most of us who are joining the space new, um, how is the sound on YouTube? Is it coming out? Let me ask you. Okay, so new them, let's meet it. So for someone who's joining the space new, getting started, Launchpad um, is managed by Protocol Labs. So Protocol Labs is one of the open research, open source platforms like the Research Institute, uh, designed to build products. And John Bonnet is leading this. And these are one of the platforms where you can learn more about it, get deep, so you don't get to be distracted. There's so many resources out there. So I think you should stick to this. What you can see here is getting started um, with the self-guided Launchpad curriculum. Um, you have the Web3 basic. Scroll down. You have you want to know about the protocol apps network. This is where you see it. I want to know about the IPFS. So you have like 10 lectures, 4 tutorials here. You want to know about Python. You have 9 lectures here. Um, P2P, IPLD, so dev tools. I know you play around the dev tools. Uh, but before we come to dev tools, let's see what this Launchpad getting started. So this is how you get started with the self-guided Launchpad curriculum. What is it? It covers topics related to protocol labs technologies and the wider Web3 ecosystem as a whole. It is heavy on topics like decentralized file storage, peer-to-peer, but does not have some coverage of blockchain and other Web3 technologies. So this is what you can see here. So the sections covers around Web3 basic, protocol labs, as I said, we've checked it. Depth levels, there are two study levels, the shallow and deep. So um, for you to make the best use of time, you have enough time to go deep. Not reach shallow, just try to go deep. You select a desired level by choosing from the menu on the upper right. Some advanced sections will disappear when you select D, you know. So these are study approach. You read through the materials, watch the reference videos, either as you go or at the end. Um, Once you've read and watch, you are you are then ready to view or 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 recorded the Q&A session. In the past they used to hold like a live sessions with engineers that talk about the questions and answers. So these are some tips you'll be seeing on the space. Keeps you busy. So that's about this. Web3 basics for those joining us for Web3. I know you must have done this, but what's Web3 actually? Um, it says in the internet. The internet is a result of humanity drive to develop more efficient ways of communicating with each other. So we all agree with that. What started as a group of universities and government agencies experimenting with digital communication is now com- a combined uh, explosion of different use cases. The internet is many things. It is tool for sharing information. It is a marketplace for comments. It is a background for artists and scientific exploration, in some cases, a den for villainies. Above all, it has become an indelible part of human experience. You can see sometimes before you sleep, you're on the internet, you wake up, your internet. Sometimes you pay more attention to internet than your Bible or than your Quran or whatever you believe on. So that's how the internet has really get into us. And you can imagine if we don't have data, it's like our body. That's how we feel. Me, I feel very uncomfortable. But those days are during the early days. You see men staying, they write a mail, post it, they wait for months, they get the response, they do the business, and the rest, men, things moving. But now you send a mail, he has not checked the mail. You're kind of like, so we're kind of like in a fast-paced world. Uh, so the internet is, as I said, so it has really developed from phases from the web one to web two to web three. Please, could you just put it on silent? The course will breeze. So this course will breeze into web one, web two, and take a bit longer into stroll into the aspect of web three. For those the web two developers here, so you could quickly digest this throughout today. Just take it out, digest it. When we're talking tomorrow, you're done with this. So I'll introduce you to another school tomorrow again. So as the internet has grown into all-encompassing machine, we see it used as particularly effective tool for political manipulations and control. So Web3 has come to like push back against that. You remember when Trump was the president earlier, you could see there was some social media gang ups. When you type in Trump, you see the opposition. But with the Web3 advent of Web3 now, all those things are limited because whatever you push into the space, for you to alter it, you must have a consensus. At least 51, 51% of the node must agree, for that change. And you can check out the stress for you to make robot agree with me, the stress for you to make the two node to agree, for the stress for you to make the mass node to agree. That stress alone, it makes you to just allow the whole thing just go seamlessly. So that's where what Web3 is bringing in here. So Web3 is an attempt to push back against this to some extent. It is also an attempt to increase individual sovereignty in an environment of increasing centralized control. So you can imagine if um, either it's if Web3 is not there, so Facebook will Mark Zuckerberg was something else earlier on, but with the presence of Web3, so many things has been like, you know a lot of things has been broken down, so many wings, everybody now is coming up. So and I so much like the decentralized world, and that's why I'm actually fully into it. That's what I like. When our God is like our God like decentralized activities. When He created human, He kind of gave us freedom. Do your thing. Give you good. He gave you life. He gave you right. He gave you left. He encouraged you to like use it well. Now to you to like abuse it, it doesn't affect him. You owns your world. He won't come and alter it. So you just allow it to do your whole thing. Than him staying and say you must do that. If you don't do that, that's not the kind of God we serve. So if we human beings now we give ourselves power, you know, you can see some of our leadership how they kind of like how they kind of make things available. So that's why I try to like lead even my own little network. I try to like put things on a decentralized level. We have a mini communities running some packages. Sometimes we kind of delegate and allow everybody to just run seamlessly, do your thing. I don't want to be like in control. So that's what we're trying to imbibe into you. So even if you go back to your own base, don't start being like a boss, but try to like mentor people, allow them to express themselves so that the network will progress further. All right, so Web3 has come. We call the direction of this movement a decentralization where power is transferred from centralized authority back to narrower, more localized authorities, ideally back to the individual users themselves. Check this word. We call the direction of this movement decentralization. For those joining the first time, where power is transferred from centralized authority back to the narrower, more localized authorities, ideally back to you and I. It's no more in Asoro, in Abuja, but rather each state is having power. So although hopeful, the goal of some of its early creators, the internet has never been a very decentralized because it misses some important properties at the root level. It has always been vulnerable to commercial and political exploitation. Centralized providers like certificate authorities, like ISPs, like social media conglomerates have stepped in to offer this and thereby created a very centralized internet. They create a centralized internet. They get your data. Uh, they sell your data. You just stay in your place. All of a sudden, you are maybe discussing about about a particular stuff, and then you're about relaxing. You just check your phone, go to Google. All of a sudden, what you're discussing with the person is already appearing on your screen. So somebody's spying your stuff. So this is like central control. A lot is happening. Um, so Web one, you know what Web one is about. So let's not spend much time about it. For those who are just the first, so Web one, these are the first phase of the internet where we have static link, hyperlinks. The email is primary means of communication. The star stores content in its file system. The media features GF buttons, graphics. If you remember the Web one page, so this is how it is. You build this, you're so happy then, man. I just remember when the US government sites used to be like this. When that was then, like when the NASA, I always like playing with the astronauts. So the NASA site seems to be like static. And it's so amazing, like but now a lot has changed. Now they were stuff like that. You're communicating and you're getting back interaction. Here comes the Web 2, and this is how it looks like. Um, this is a Starling Lab on LinkedIn. So um, this is the features, and here comes the Web 3. Um, so Web 3 refers don't allow you to distract you. Just join the class. Um, since this is working and this guy is okay, I think you're fine. So Web 3 is here, and it refers to the invention and adoption of technology, which allows for decentralization of the internet. So this started with the use of file sharing protocols such as BitTorrent, if you've read about it, and anonymizer such as TOR, but has expanded into whole self-governing and self-funding ecosystems such as Bitcoin, Ethereum. It includes the use of peer-to-peer communications, decentralized compute storage, cryptocurrencies, and the concept of sovereign identity, which are still being worked out. The key innovation of this technology is the creation of network that no single entity controls anyone, no single entity controls. Anyone can join, and yet everyone can still trust. In order for a system to be truly decentralized, it must provide these properties that are not subject to control by one authority. So it must be discoverable. Users must be simple to discover and connect with other users friendly. Authentication users must be able to self authenticate themselves and verify their communication. Coordination users must be able to communicate, with each other and form groups. Openness must provide useful services with equal access to any users. Stateful must be able to like retain information and configuration. Privacy must be capable of preserving the privacies of its users. In Web3, developers will no longer build or deploy applications that run on single server or that store the data in a single database, but hosted and managed by a single cloud service provider. Web3 applications, aka decentralized. So when it comes to Web3, we're now calling it dApps, decentralized application, not application, decentralized application. That's dApps. So and then how we write it, the small d with a capital A with small pps. Um, we run on a decentralized network of many peer-to-peer nodes like blockchain users. You might ask, what is node? Let me ask, what is node? What is a node, Ibrahim? What is a node? It's a what? What network is that? So it's basically, let me know what's your time. So you want to, I use suppose you pick that on a quick sheet. You don't need to answer. Okay. You who was yeah. No, like you say, like computer. Several computers connected together. Okay, so that's the thing. So several, not several, yes, several computers. Several computers with the same features. It's servers. They have the same. It must be this node and this node must be able to see each other. The same feature actually. It's coverable, whatever it is. That's it. It qualifies to be a node. So if you want to alter, if you want to make it change, if you take that and you want to make it change. So this, like we're all nodes now, and we're all computers now. We have the same features, we have the same everything. So we're all connected to ourselves. Now we push that now on the chain, like on the chain now. And we want to alter it now. So we're about 20 of us, about there's a concept around this. The question is, how do you communicate that? How do you communicate that? I think I experienced it around the world, in my opinion. Korea, so so across. How do you? So that's the beauty about Web 3. Okay, so where are we again? This is not a good way to but mostly okay. So I just explained the nodes. My blockchain using different set of protocols. And now in the blockchain world, we have what we call protocols. We have what we call every chain coming up with their own protocols. These are like standard communication protocols, like the Ethereum now. They are coming up with different AI. Hope this is not starting time. So maybe you guys can connect your laptop. Is this like this for working? It's not working. They're working. It's something that working. I think we look. It's so okay. But something that happened. How do we connect? Leave so I not affect yours. Let's so we have to stop it now.
Maybe there's a socket extending to that socket.
But I was like, maybe just let's go. We don't see that. Okay, so there's not a good way to represent the look of Web3 because it is mostly about transforming infrastructure to be more decentralized. It is not just about cryptocurrencies either, but comprises any effort to provide internet services in a decentralized manner, either money storage, computation. All of these logos represent groups who are building in the space. All right, so these are some of those. These are some of the groups building the space. You all can be part of this. So that's why we're driving you so that you guys can be you can have your own products here, you can have your own solutions here, you can have your own works here. So these are the guys contributing. So it's not about cryptocurrency. So most times when you talk about Web3, you're telling me about crypto. I I don't have much knowledge of that here because I'm not really into trading and all that stuff. So even when the market is going down or not, I'm not really into it. So I try to be on the equity side. So that's where I make my money, and that's where that's where it be sanity. Like, so I want you now choose where you want to go. There is the trading aspect, there's the contributing aspect, the building aspect, and other technical aspect. So as I said, it's not about cryptocurrencies because a lot of us who came, some of the OGs in Nigeria who started this stuff, very robbing people with coins and stuff like that. I don't want to mention them, but we don't want to fall into that. So we're trying to like raise some good guys who compute useful assets and then raise some grants and stuff and try to like see how your business can sustain the test of time. And we're actually out there to raise good actors basically. So that's what we're doing here. We believe out of you guys will not go out and start creating one point to like pull people again. But rather, if you're building something, it should be meaningful, it should be impactful with a very good thought. So so these are stuff. Some of these things started from hackathon. We're also trying to see what people can organize a simple equal hackathon here. I'm trying to talk to a few friends, if not because of this. You know, I live in the lecture, the mentor is around, so it would have saved me because I would have started engaging people right now. But all the same, we're trying to see how we could act. At least before you go, you guys get richer. That's what we're trying to achieve here. All right, so this is the founder of Protocol Labs and the founder of I think I posted him on my X as well. So we met one of those trip I traveled out there. A very cool guy and very young guy, basically. So he's the guy behind the Python space. So when you come to this thing, you go play and learn more about what is a building or a tree. So read more around Wikipedia, check for Web3. Okay, these are the source of this article here. Now that's about Web3. What about cryptography? So that's another field, very interesting. I really want to raise some cryptographers. Let me start about cryptography. Yeah, so that's something that I was discussing with Dr. Odemuyiwa. That's is overseeing this talk in really large with the computer science department. So about raising some cryptographers, like core cryptographers. So it's a very good field that if you go like the hot take, take your time to start. It's very broad, and we need cryptography in so many stuff we're doing. Yeah, outside being a developer, there's still much more. You can still, you know, separate yourself from others. And so what's cryptographer? Overview. Communication is the root of user sovereignty. Communication is how we solve problems, establish corporations, and control our precious lives. Cryptography is a set of mathematical techniques that allow one to scramble communication. All right. For those from our friends on the view on the YouTube, I hope you guys are following up. Um, I wanted to say something off the call, but let me continue. I just remember. So you guys, I heard you guys had some great stuff last night. Please, some people are sleeping here. So you guys kind of like mellow. So this kind of environment kind of like expose our character, but how do you manage each other? So these are one of those things you learn on this field. So that when you get into your network or you got married or whether you get settled, you're able to like manage the next person who you don't know from anywhere. All right, and that's if there's any other thing, there's fire extinguisher. All right, so no, there's first aid. What's out there's aid one? All right, go. I just been safe, yeah. So the use of cryptographic technology. So cryptography is a set of mathematical techniques. So that's why we kind of said, okay, before we start this stuff, why don't we just wake you guys with mathematics? Kind of like just you guys start opening your algebras, and stuff like that. And Faith has been doing wonderfully on that. So cryptography is a set of mathematical techniques that allow one to scramble communication in such a way that only that person can specify how to unscramble the communication. So it's very good if you can take your mathematics very serious. Like every day, try to open mathematics and get in. Most of these astronomers are doing amazing stuff in the space. They're very good with mathematics. You know, mathematics have a way of opening, kind of like simplifying a lot once you understand this. Um, and once you understand it very well, some of the code you are writing, just a single line has solved so many things. So how good you are. So just pay attention to your mathematical skills. Um, it allows one to scramble communication, as I said. The use of cryptographic technologies become ambiguous in the Web2 space, and now on the gives the internet using HTTPS. All internet traffic is encrypted, so only those authorized may view it. This form of encryption requires the use of centralized certificate providers. In Web3, cryptography is moving away from that, from that self-issuance. Um, um, can you pick the call? Tell him if he's around. Okay, got something. Pick the call. Okay, so cryptographers are the guys behind the encryption, coming up with how to conceal the message. A lot of things will be happening in space, but you don't know. But if you can decode it, you get it. So these are the work of cryptographers. Encrypting, they are behind the authentication. So if you go in very well into cryptography, so these are some of the opportunities. You could be exploring around the encryption world, the authentication world, the verification world, the repetition world. So these are some great world, and uh, verify that message was not altered. So reputation prove that something occurred at a given time. Authentication prove therefore not right. So that's history about cryptography. In the 1930s to 40s, decryption of German encryption plays key role in World War One. If you can decrypt the German roles. So Alan Turing advances cryptography in computing. That was the mid-century. So cryptography is primarily used for defense purposes. So it's a great work that we need to pay attention. So these are some history about the cryptographies, the NSA, government and stuff like that. So if you go through it, it's now from there, Bitcoin. Okay, so so these are the genesis of the cryptographies, and now from there you have the hash cash first proposed. This is the precursors to Bitcoin proof of work in way back in 1997. In 1995, we have the hash algorithm as well. So it has been on stages. In 2025, in 2000, U.S. government announced restriction on export of cryptography are relaxed. So announced restriction on export of cryptography are relaxed, although not removed. So this allow many US companies to stop the logging running process of having to create US and international copies of their software. So this is about that. So in 2008, Bitcoin white paper was published by Satoshi Nakamoto as an electronic payment system based on cryptographic proof of work instead of trust. Then a Ethereum white paper also was published in 2014. In 2017, Python white paper was published as well, leading to digital currencies. All this, and with cryptography, we can now look at ways to use it to accomplish our goals of increasing user sovereignty. So that's why we as an African, we need to like take time, read these things and get inspired and see how we could make something out of, in our peculiar world as well. So read much about this. I wouldn't want to go much in it. You try to really look at the Sarah Funk manifesto as well. Then you know about the zero knowledge too. For those hearing what the zero knowledge is about, zero knowledge proves that cryptographic methods and strategies for validating information without revealing, data that you want to keep private or secret. Through this technology has application in cryptocurrencies. The applications are wide and provide benefit in applications. This is my first time Lawrence sent me a mail. Lawrence is uh, is one of the guys coordinating DEFCON so in Nigeria. So he sent me a mail. Then he asked me to like um, encrypt. There's an email. There's a Gmail encrypting format he shared with me. I was like, what? So I just discovered that I kind of like follow what he asked me to do. I sent him that what he received was just codes, So whoever is trying to like hack, whoever is on the network, will be able to decrypt it. All this way we send like this, people can always, if they mean you, they can always access it, read through. But I sent so anything I was sending to Ethereum is being decrypted, and they receive it, they'll be able to like unzip it from their end. And if they send it to me, it's been encrypted rather, and I'll decrypt it from my end. So it's quite interesting, man. And very soon we see more of this world. At DEFCON, I think I saw some ZK email, and these are not just like the normal emails too. So we'll be seeing more of these solutions on the space as well. So really take a look around zero knowledge proof. It's an interesting field, which I want us to explore sometime, some other time. So blockchain, Bitcoin. What's Bitcoin? You know about Bitcoin. Who has one Bitcoin in his wallet now? You have it. Wow. 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 I trust my girls. I trust my girls. Ah. Oh, wow. So, say one Bitcoin. Now with a now, so it's interesting, man. So blockchain is just another word of a ledger and or a database or an accounting system. They are special because they can store information in the open within a hostile environment, but still in a trustworthy manner. So Bitcoin and its derivatives are called blockchain because of how they store information. Transactions are grouped together into blocks that are linked together like a chain. The chain is what gives the system its strength. Once a block is linked to the chain, it can no longer be changed. So a transaction is the smallest unit of information in blockchain. A transaction is a request to send some amount of tokens from one user to another. A transaction can also be a request to store a piece of data into a permanent record. So anyone can send a transaction to be included in the blockchain. Transactions are sent to any of the nodes, servers of the network. Transactions are accepted by every node into a temporary pool. After a period of time, a selection of transactions are sealed together as a group and written into the permanent memory of the network. This group is called a block. When it's been sent, you receive notification. When we've all agreed, then it's signed to become a block. It's added. Okay, so that's so blocks are very unnecessary because the sealing action requires a significant amount of effort. It would slow things down significantly if every transaction was sealed individually. Each block is linked to a previous one after another in one long unbroken chain. That's a blockchain. So it's a chain, a block. So the blockchain has some unique properties. No one is able to make any changes to the chain once it has been committed because they are cryptographically linked. Changing even a single bit would disrupt the link and be detectable. The chain also is guaranteed that the ordering of transaction remains intact. No one is able to grant themselves free tokens or spend their tokens in two places at one time. The consistency, this consistency satisfies of our sense of fairness, which makes us willing to use it as an accountable system for value, saving, and transfer. Some properties of this blockchain are what? Immutable, attributable, decentralized. So these are like the blockchain. Um, so this is the picture. If you want to visualize blockchain, this is a transaction that's been initiated. This is the data that is packaged like a block. The block is sent to these nodes, and this is you. This is robot. This is Ibrahim. This is this is Simon. That and that's the block receiving it. And what next? The consensus. This system all agree, and once they agree, it's being added to this block. Now this block is added to the chain now. Now this is so it is updated and is distributed. So remember it started with one and same process. One is being agreed, it's being added. It's not okay. So you so all this are being interpreted. So you have the block one, that's the header, the block two, the block three. So, and they are being hashed, and you use the maker root to link it up. So these are the transactions. You can read it if you I don't know if somebody have studied the Merkle tree. So that's another stuff you could also learn. So consensus. This is consensus. Consensus is the process whereby nodes that don't know each other can come into agreement regarding the validity or an ordering of transactions. So that's consensus. So for anything to be changed, this node must agree, or for anything to be added, this node must agree. So decentralized consensus is difficult because it has to work even when there are some number of hostile actors who are deliberately trying to game the system, even at own cost. In the case of most blockchain, as long as greater than 50% of the actors are rational actors who play by the rules, the system will function properly. Greater than 50. So how do blockchain ensure they retain a majority of good actors? There's no guarantee, but there are ways to encourage successes. So that's why you have the incentives, and they're constructed in such a way that playing by the rules will yield a greater result than breaking the rules. An actor who assaults the system maybe change a significant fee, maybe charge a significant fee taken from the bonded collateral. Ultimately, an actor who damages the network permanently will end up with a network that is not worth anything. This kind of game theoretic incentives have worked so far, although there have been hacks and other minor exploits. The system have been proven to be stable and trustworthy. The hacks and exploits will reduce in time as this system matures. So another good thing about the space is security. So you can also explore blockchain security as well. That's the hot cake as well. So how do consensus work? Bitcoin consensus innovation is called the proof of work. Nodes are also called miners. The network competes to solve cryptographic problems in order to earn the right to add a new block onto this blockchain. The faster miner adds the newest block to the blockchain and is awarded with tokens. This practice requires immense processing power meant to discourage attackers. As a payment for their work, for that work, the node receive the block reward, amount of new token minted out of thin air, as well as transaction fees that are associated with the transaction or in the block. So in the Bitcoin case, the block reward also served as its initial token distribution mechanism. The Bitcoin started with 0 Bitcoins, and then each block was mined, and new 50 Bitcoins were created. These tokens were worth nothing in the beginning, but have quickly gained value. The rate of issuance is slowing down and will eventually stop. This has produced a stable system with a very small inflation rate that will eventually go into zero. So you can read much more about this. How does one get blockchain tokens now? You read about here, Coinbase, Cracker, Binance, Jam. So these are some places. How much is a cryptocurrency worth? You come down here, you go to this aggregators, the marketplace. You can see the coin, the cost of the coin, and then you can now convert it to your local currency as well. So these are some of the additional materials for you to explore on blockchain. So, and how does blockchain work? So these are stuff for you to explore. So now let's go to wallets. All right. So the wallets. The last time Vitaly said encourages us to build more wallets. So it would be nice to for you to start looking at building your wallet. At least we have a lot of wallets we use, but wallets from Africa as well from us. So how do users establish an identity with a blockchain and authorize transactions to be made from their account? Anyone can join the blockchain with like Bitcoin. All it requires is to create an identity and find someone to transact with. So an identity is nothing more than a large random number that each user picks for themselves. As long as the user uses a system that picks a true random number and never reveals it, no one will be able to guess it. This is true because the field of possible number is so vast, more than the number of atoms in the universe. That's the possibility of guessing another number. It's effectively impossible. So, using cryptography is a secret. Number is used to create a family of new numbers, and that's how these numbers are being generated. So how does a user keep track of all these numbers then? A wallet. A wallet is used to keep track of these numbers for the user. A wallet are software applications or hardware devices that abstract away the maths and the numbers, making it easier and more natural for the user to interact with each blockchain network. So you can have your wallet. You can also have your hard wallet. I think I'm going to look for my hard wallet so that I show you how it works. I don't know where I kept it, but so if you don't want to use MetaMask, you can use a hard wallet to save your details and stuff like that. So wallets are your therefore going and therefore gateway to blockchain. So without wallet, you can attract to those chains. So they're actually a gateway for you to get into this space. Okay. Wallet can manage collectibles, coordinate membership in DIO, stake, trade, farm, swap, and migrate of their use cases. So I'll hold on here. Let me get some questions. But these are the types of wallets. I don't know if you want to answer it. So let me hold on. Check if there's any question on the YouTube space as well. So do we have questions or contribution? Who wants to add to it? No, connect the thing you get with. When you have something in the phone, just connect. Okay. So, yeah, you were saying something? As if you have a friend and maybe for instance, you stop. Doesn't affect that. No, it doesn't affect. Yeah, that's it. So a very good question now. Now we are all notes, and if Ayomide leave us, and then maybe he's busy with his wife, he's smiling. The businessman, the importer and exporter, Chumaya, he goes to Japan. Will the note still work? Yes, it will still work. It's still so it still works. So whenever he comes back, he gets updates. He gets updated. His note gets updated. And then exactly, and then continue running. So whatever. So that's why. Yeah. Okay. So that's why is people you are being paid to always be online. So you try as much as possible. Even before you come into the space, you must have agreed. You have before like you have network, you have backups and stuff like that. So it's not really very rare to see that, except in the case of maybe natural disasters like an earthquake. Oh my hand, that's a different. But still, the nodes in Africa will be supporting, depending when they resolve their stuff. So the space, the blockchain is still moving. It's not like yeah, it's still the business still goes on. So there are several ways to classify cryptocurrency wallets: the custodian versus the non-custodian, the software. Yes, please.
Correct. And mining. Just right between like mining and
The nodes, the node providers are actually miners actually, because for you to maintain a node, you have other functions to be doing. You have a system, yes, you are watching it. Then for you to mine again, you make more money. So you have to. I think I said it there. The nodes provider. So if you're coming to the space, then it has a lot. Like, so cost. Yes now. Yes now. So
set up to run in. Yeah, it's part of the so I think for 5 points, running with the 5 points, there's a market you have to get original. You have there's a storage market where you have to get into and things like you making use. That's why this data you see the smart contracts with there's this data with some programmatically work with. So it's like there's a bit of you have to know someone that's already doing it to give you. So I remember that there was a class I was in and it taught us how to mine be a Ethereum node, be a because I know fucking Nigerians have been doing it for a while.
so yeah. The Bitcoin's serious. Is a serious. The Bitcoin miners are big, making big. You know what it means. So several ways of classifying cryptocurrency wallet. So we have what we call the custodian and the non-custodian wallet. Can anybody differentiate what is custodian wallet and non-custodian? Okay. Are you speaking? Can you differentiate what custodian and non-custodian wallet is? No, speak out if you're speaking. So yeah, you want to say something? Yes. Okay. Okay. Who wants to help out? Who wants to help out him? Hmm? What?
I think custodian. Not custodian like binary. Centralized finance.
I think you guys are mixing. So they are custody. So that's oh. Okay. So what about the software and hardware? The software and hardware. Huh? Can we make it? Can we just harmonize our discussion? Yes. To me, when you're talking, you're saying something. To me, when you're speaking, right? You said what? Okay. Can be. Huh? So like offline backups wallets. So these are like software. Then what's the hardware wallet? Okay, please remind me. There's a one key wallet. One key. You know one key. So they sent me their wallet. Yeah, wallet. So I'll bring it so that we'll see it. So that's like a hardware wallet. Now, what about browser wallets, standalone wallets? Browser wallet, standalone wallet. Browser wallet. Okay, so who is saying contrary? Okay, okay, okay. Who is giving us? So, it's you said browser. A standalone wallet is what? Okay. So who have used Exodus wallet? Exodus. You have it like okay. So that's like a standalone wallet. Um, self-contained crypto wallet. Then the single wallet. What about single wallet? Like just one single sign, just like your MetaMask now, you alone sign. Then the multi-sign, what about the multi-sign wallet? So you have like two. So we can have like we can create a multi-sign account. So maybe we have three, four signatures. So for we to make any transaction, three or four of us must agree and stuff. So that's the multi-sign wallet. Yeah, exactly. So you have the direct plus abstracted wallet. Okay, let's proceed. I think we've made tremendous. Uh, that's on the wallet, and you've gotten your you all have your Falcon wallet, right? Okay, you all have your Falcon wallet. All right, so this is hot wallet. This is your cold wallet. This is how it looks like. The hot wallets are compatible with your desktop, mo- mobile, your web. The hard wallet, this is it. It could be in this form as well. So this is it. Custody repeated. So you have some hard wallets, ledgers, Trezor, and Degrave, Keep. So this is it. Conventional smart contract, MPC, custodian. So this is it. Um, these are conventional smart contracts, MPC, custodian wallets. These are some of them. So these guys owns have some of your have access to your wallets here. But this is when you're talking about Web3, this is it. So if your money lost, it's lost. Can't be, you know. So that's why you need to keep your Keep your private key well, keep your seed phrase well here. Smart contract abstractions. So,
Agents and browser.
okay. So the most important thing about a wallet, if you lose your wallet or are all your assets lost, not necessary. First of all, the wallet does not store any of your assets. That information is all stored on the blockchain itself. Your wallet only store a copy of the keys that permits you to transact with them. Wallets always provide a way to back up themselves. This usually involves writing down a set of words that act as a recovery phrase. Always take the time to record your recovery phrase or store copies in one or more safe locations. So look at these videos to learn more about the crypto wallet, and that is about that. So I think we'll be pausing here. The next one is learn about smart contracts on Ethereum, play around this, get familiar with this terminology. still on the still what we're doing. We're trying to wrap up with it. Smart contracts. So you try to read this, get familiar with this. It talks about smart contract security. Um, Here you learn about what smart contract is. Um, what smart contract is simply a program that is written um, and deployed on the blockchain. So once deployed, it cannot be altered, and um, it's allowed programming. It's immutable, and then so when it's augmented with open source validation of integration, it allows contractors to develop a reputation of consistency and trust that will encourage other users to interact with. So smart contracts help to perform useful actions that can charge fees of its users and become profits, for the creators as well. So it's simply an agreement. When agreement is meant, it's an execute it will execute, and if it's not meant, it declines. So this is like a um, agreement, automated agreement basically. So read this more regarding security consideration. You read about this, and then hello, are we together here? Hello. Okay. Okay. I understand some of you have passed this phase, have passed through this phases, but some of you are still it's still phrase, it's sounding phrase. So just taking our time to get through it. But have you gotten this curriculum? So I'll drop it for you guys to just go through it to keep you guys engaged on. Okay, I'll drop in the group as well. So okay, that's fine. So what's token? Can somebody tell us what's token like? What's the token? What's the token? Yeah. Yeah, awesome. So a digital asset. So it can be exchanged for value, you understand? So so read about that. So we have the fungible and non-fungible tokens as well. So read about that. Um, so this is kind of an illustration on the NFTs from 2024, down to 2021. It's not yet an updated. It's not yet an updated version, but this is how it has metamorphosed over time. Um, so go through this document. It's very rich. It gives you like a great startup, and it helps you to to learn more. It builds your vocabulary in the Web3 space too as well. I think somebody right, so this DeFi as well. What's DeFi? Okay, so you guys are already good as well. So DeFi projects can be DAOs and many as well. So you can think DeFi in many areas in the blockchain space, transaction of history of state of accounts. So these are some of the parts around that. Use cases. You can see the use cases. You can see the advanced use cases. Look at this scaling. Look at you guys to look at scale. What is the meaning of scaling?